All my viewers. I am here today to shed more light on this particular topic. I name it as setting overload current relay on rated currents versus measured running currents. That is on full load. When the load has been applied and is operating on full load, then and I say explanation with practical analysis. So this particular 45 kilowatt motor have a fan attached to it as a load. So uh, I measure this current on red phase to be 49.7 amp, yellow phase 44.8 ampere, blue phase 45.2 ampere. I calculated for the average of this, I got 46.6 ampere. This is the applied measured voltage. Now, red to yellow phase, I measured 411.6 volts, yellow to blue phase, 409.3 volts, blue to red phase, 410.0 volts. Then the average measured voltage here, that is this plus this divided by 3, gave me 410.3 volts, and the frequency is 50.29 hertz. Then the actual power based on the applied load to this 45 kilowatt motor, using this formula, power is equal to IV. I is current, V is voltage, then root 3, because this motor is a three-phase motor, phase to phase 415, then multiply by cos phi, multiply by efficiency. Now, the average current measured here, multiply by the average voltage measured, multiply by root 3 is 1.7321. Then the cos phi, power factor 0.77, and the efficiency is 96. Then 96 divided by 100 give us 0.96. If you multiply everything here together, approximately we have 25 kilowatts out of 45 kilowatt motor designed. So this load attached plus everything together with motor is 25 kilowatts. Now, I now calculated for overload set points at 115% of this running current measured, which is 1.15. It means my overload set point based on this actual load this motor is driven or running on, which is the fan. As I earlier mentioned, the overload set point will be on 54 ampere if the service factor of 1.15 is used, or if that is what the designer or the OEM of the motor designed, you use this. So, assuming the OEM of the motor designed this motor to be 1.25, which is 125%. Now, I now calculated 125%, which is 1.25 of this actual current drawn by the motor. The overload set point for this will be at 58 amp. And what is even a service factor? In a simple term, let me say something about it. A service factor is that additional load, or let me say the allowable load or current permitted or permissible for this motor to run under few period of time. Is not designed to be run for long period on this safety on this service factor. Now, if I want us to look at this, if service factor is 1.15, the overload set point will be at 54 amp. If it is 1.25, the overload set point will be at 58. Now, this is based on the actual load being coupled with the motor 45 kilowatts. Now, I now do calculation based on the designed as designed by OEM. Look at this. The motor is designed or rated to be 400 volts, 45 kilowatts, cos phi 0.77. Then the rated current or design current is 87.5, IP55 S1, that's duty, RPM is 1482 revolution per minute, frequency is 50 Hz, efficiency 96. Then I now tag this as confirming the motor design using this power formula, IV root 3 cos phi efficiency. And truly, when I verify that, the motor happened to be 45 kilowatts. Now, overload set points at that, this is a 1.15 service factor. Look at it, the 87, which is design current, times this. So we have 101 ampere, meaning that if you are to go by the nameplate rating, the overload set point will be at this, at service factor of 1.15. Then at service factor of 1.25, then 87.5 ampere times that will give us 109. Please, I want to ask, if you are to set your overload based on this actual running current and based on this design current, which one is more safer? Me are looking at it is this one, because what this one mean is that this particular installation is drawing 46 out of, that's 46.6 out of 87.5 designed, meaning that with the service factor multiplier we have this 54 and 58, meaning that at the instance of abnormality or increase in current due to load or due to stiffness of bearing, due to damage to bearing, or whatever that might make this abnormality to grow from this particular rated running, which is 46.6 ampere, with this safety multiplier, which is service factor. It means this will respond based on any problem that comes to this. As compared to this, what this one mean that for overload setting to be on this, on the O or this, based on this two service factor, it means current that is running on this, the motor that is running on this will build up to reach either this or this before motor will trip, of which the current may not even build up to this for many hours, for many months, for many weeks. So meaning that it is more safer to set your overload based on the actual current drawn by your installation instead of using a design current. Although if due to one reason or the other